how do we actually find things? Like, instead of just thinking, let's find behaviors, we start to think of how do we become more efficient what we do? And from that experience with working people, we start to learn that there's some pretty regular trends across the board that people see within their security operations. And really, there's just 5 key challenges that can be distilled down. The first one, it almost should be obvious, but it's funny because the way we buy vendors isn't consistent with this, that attacks don't really think about, they're not network attacks, they're not endpoint attacks, they're not cloud attacks. Attacks simply leverage what attack surface exists today so that they can A, get in, B, gain an initial foothold, and then C, pivot to whatever critical resources so that they can ultimately steal data, destroy data, or encrypt data, and whatever the intent, or disrupt. And the fact is the attacks leverage network, endpoint, and cloud. In fact, today there's a new zero-day Zoom vulnerability that, Zoom's been in the news quite a bit lately with all our stay at home. $500,000 for this 0 day for Zoom, because that's the new normal and that's the new way in. They're not using Zoom necessarily to, it might be to listen to a conversation, but a lot of these 0 days for Zoom are just ways to get into the network so that they can start to spread further, which would be through a lot of cloud endpoint, things like that. So the short of it is that the attack surface, attacks just don't care about what it is, and you have to think of all these things. The second one that gets the news quite a bit is the shortage of qualified personnel, which we've known about forever. It's interesting because security is one industry that has never had a problem with enough people. We don't really think about, it's an actually interesting thing when I talk about, so doing machine learning and data science, we think a lot about automation, and we're gonna talk about that later here. That in many industries, when people hear automation, they're like, oh, are you replacing humans? We don't really think about that in security because we don't have enough people to begin with. So as many as we can take or add, the better. And of course, that shortage means that the people that are there having to do the work are exhausted of the work they have because there's a huge volume of it. And I think there's a huge volume of work because security products, again, as we mentioned before, security products tend to work independently and tell you they're going to solve the world, and we all know they don't. Everybody solves a specific problem. You end up with anywhere from 10 to 50 products. I have seen a network where they had over 50 vendors inside, and they were like, we need to really figure out where this fits and what do we do? So when you start to have that many consoles, it's really hard to figure out how to start your day, where to go to next, what is the workflow around it. These are a lot of things I've seen within security operations processes, which I think also, all these are connected, of course, leads to these long attacker dwell times. Many of the processes are reactive, and by reactive, what I mean is that somebody gets an alert and they respond to it. Proactive would be you went out there and you spent time and understood what your network and your endpoints and your attack surface looks like, and you're able to start to look for things that you should be concerned about, which is a desired state, but the reality is because of shortage of qualified personnel, siloed products, people have become reactive. You're having to deal with each thing in piecemeal, and you're not able to put it together, which leads to, I think, the ultimate problem is money, cost. SOC budgets become strained with license, employee turnover. It's, the average length of a tier 1 analyst tends to be 6 to 12 months tops. And that's quite normal because it's a really hard, tough job trying to manage the amount of alerts coming in, things going on. The minute a tier 1 analyst, and because there's a short of the qualified personnel, the minute a tier 1 analyst is qualified enough to do something more and do something better, they usually do. And they should, by the way. You should promote that your junior guys slowly move up the stack and that there's a career path for them. So, but there is a cost in that of constantly having to retrain. And there is a cost in having 10 to 50 products in your SOC, all vying for attention of the limited staff, all trying to work together. So what this SOC triad is about is how do we solve for this? How do we condense this to make a faster, more efficient SOC? And the quick answer to that is it starts with visibility, and it's in the name. When you think of SOC Visibility Triad, it's there. And Muhammad Ali was a very let's call him chatty. He was an interesting fellow because he always had a lot of things to say, but the quote that defined him most was when he said, "Float like a butterfly, sting like a bee," and more importantly, the hands can't hit what the eyes can't see. Even as a fighter, he knew it wasn't enough to have a strong punch or strong capabilities, or for you, a strong analyst. You had to have complete visibility to this entire attack life cycle, to all these different places attacks go when they pivot, when they change. If you can't see and you don't have visibility, then you can't be proactive and you can't respond. So the way Gartner defined that, this quote is from a paper that they put out in March of 2019. And in the blue, quite simply, your SOC triad seeks to significantly reduce the chance that attackers will operate on your network long enough to accomplish their goals. And it mentions there's 3 points of it being logs, endpoint data, and network data to give you full visibility. And before we talk about the product categories and things like that, you have to step back and think about more of the data source, being again, logs, endpoint, and network. Because to get visibility to cloud, endpoint, and network, you have to have data from all of them, and you need that working all together. And the point of that is using them together severely reduces the chance that an attacker can evade you for extended periods of time. From this, the Gartner SOC Visibility Triad, the goal ultimately is to get functional harmony. You know, in music, a triad is described as a set of 3 notes that can be stacked vertically in thirds to create a harmonic triad. In security operations, the SOC triad, while it's not stacked vertically, it's actually all aligned, provides greater visibility in your environment by harmonizing the 3 distinct capabilities of network, endpoint, and in this case, SIM, which tends to equals logs, reducing the likelihood of a bad actor staying hidden for an extended period. And this is a really important distinction here. The visibility triad is not about preventing attacks and stopping them and doing things like, so if somebody gets a 0-day to Zoom and infects a desktop at home, the reality is that's going to happen. We all know that phishing emails, scams, all the things that happen, attackers have always been good at getting on networks. The goal is to detect them soon enough to reduce the likelihood that they're there for long enough to ultimately achieve their goals and to cause damage. Again, disruption, data theft, encryption, ransomware, all the things that they like to do. Quite often these days, they like to do all of them. And the SOC Visibility Triad looks at the NDR, network being network detection response, endpoint being endpoint detection response, and then SIM, user entity behavior analytics tied to logs. The belief is that by putting all these 3 together, you get visibility into the attack lifecycle. So talking about that more, as I said, the goal here is not to prevent, it's to see the attacks as they occur and to get enough context about the attack to be able to understand what an attack is doing so you can reduce the impact. Within cyber resiliency, we describe it as assume the breach, reduce the impact, quite simply, and it's a very good philosophy to live by within security operations, because in security operations, if we see things, it already happened and now you're trying to reduce it. So it becomes a question as we talk about visibility from network, endpoint, and logs, what is it we're really looking for? And over the last 20 years I've been security, I've played with all this stuff, we've looked at it, and what I've learned from a detection point of view is that all detection has a value, you just have to know what that value is. In this case, what we're really focused on are tools, tactics, and procedures, which are the behaviors an attack has to perform in order to succeed. And they're incredibly difficult and expensive for the attacker to evade because they have to do them. And I'll give you an example of that. So let's candidly, now that everybody's working at home, external remote access is a thing. And then external remote access leading to privileged access is now a thing. And that's quite common. It doesn't matter if you're a regular user or administrator working from home trying to get to your servers, or you're an attacker, you have to exhibit a particular behavior of pivoting from external remote access, using privileged access to a critical asset, and then doing something like moving the data out or encrypting. These are all descriptions of behaviors, and they're best described in the MITRE ATT&CK framework, which starts to describe the entire life cycle of cloud, endpoint, network type behaviors that can occur. As an attack, there's no way around that. And it doesn't matter if, say you're on a Zoom session, somebody had that 0 day, there's still a behavior in that. Say the person wants to pivot or scan your network, there's a behavior in that. These behaviors are the most durable thing within security to detect, and it increases the cost of the attack if they don't want to be detected. It doesn't mean things like signatures and threat intel are bad. Actually, they're still valuable. They're very good at the known things and things that happen immediately. And there's been a lot of work actually around the COVID threat intelligence. I want to give a shout out to that group. Been monitoring and participating, and it's great. And there's a connection with the community to build immediate signatures and threat intel around current actors and things that are going on. That's awesome. And it's really useful and something you should plug into a program. But it's also very immediate and it has a short shelf life. So it's good for something to happen today, but as we all go back to work and the environments change, then the types of signatures and threat intel have to constantly change with it. So it is a good thing and you want it, but it cannot be the basis of a full program. And what's really important to the SOC Visibility Triad is focusing on these behaviors. The other good news is that behaviors are great for machine learning AI detection models, because it takes a while to write a machine learning algorithm. That's something no one ever talks about. So threat intel can be written within a matter of minutes, hours. It's as things happen, you're able to write a signature, you put it in there, you know what it is, but they also tend to only last for minutes or hours. Machine learning models can take months to build, but the good news is that when you focus on tools, tactics, and procedures, they last for years. Many of the models that we built 5 years ago are still valuable and valid today, and even though the landscape has changed. So even though we've seen changes in the way ransomware occurs and the way the environment changes, the behaviors have been consistent. And the way that you build behaviors is combining security research and data science, which is great news, by the way, for all the security researchers out there. It's you need both. Data science alone doesn't solve the problem. You first need to focus on identifying, prioritizing, and characterizing the kind of behaviors that happen. And when you put those together, you get these high quality signal. And again, this doesn't matter if it's network, endpoint, or cloud. This is across the board. You want to start thinking about this combination, which ultimately gives you visibility across the entire attack lifecycle. So as we talk about the SOC Visibility Triad, I really think of the attack lifecycle, again, this maps to MITRE, as it pivots through all the different stages of what an attack can do. And every single behavior that can occur, if you look at the MITRE ATT&CK framework, could really be mapped to a detection type model or a specific thing that can be scored or qualified or quantified or however you want to look at it. The ultimate goal of this, if we think about the SOC workload, is to take that attack life cycle, and once we map it out, we're able to start scoring the entire life cycle based on what it was. Every attack, as I said, ultimately is trying to steal data, disrupt data, encrypt data, whatever it's trying to go. There are some opportunistic threats, which think of botnet monetization. Take, for example, or most prolific would be crypto mining. That happens quite a bit. They're not trying to steal data, but they're trying to leverage existing resources for their own gains. So you get spam relays, crypto mining, things like that. Those are an example of attacks that are interesting and something you should care about, but it's not the same as an attack that starts to pivot onto the inside and look for critical resources, use things like remote desktop or use privileged access across server ports with the ultimate goal to acquire data and all doing this through manually crafted and custom command and control through hidden tunnels and things like that. The great news is that when we look at this visibility model of attacker behaviors across the entire life cycle from east-west movement and things like that, we have a better opportunity of not just detecting attacks, but of prioritizing the attacks we do find, so that we can start to differentiate the type of behaviors. And instead of just telling you there was a malware on a laptop, we can actually be more explicit and say, well, this guy was targeting your desktops to do crypto mining versus this attacker is trying to steal your critical data that's going to put you out of business. And when we differentiate, we're able to start scoring every host on the network in real time based on the type of behaviors we see on it. So if we saw just privileged access but no command and control, that's important, but it's not as important as saying I saw the entire attack lifecycle happen on this host within a certain time sequence, within a certain order. So what we've learned that leads to is automation and workload reduction on the front end of what I'm going to show in the process of the SOC Triad, which effectively is the tier 1 analyst work, where rather than just having visibility to malware that occurred, when we see the whole attack lifecycle, we're able to distill that data down from just singular events, being like a malware binary exe would be an example of a singular event. We're able to distill that down more to like, well, this was an entire command and control that used malware, to this was privileged access over remote desktop. Like, you start to get these bigger pictures to ultimately be able to take that attack lifecycle and distill it down to hosts so that we can say what is critical, high, medium, and low. The example I'm showing here, again, part of my job is doing analytics globally, is that I'm able to collect data from customers and its metadata to understand some of the statistics and things we've seen. And we normalize that data across 9 different industries so that we can start to understand comparatively from metrics, how do people score and what are the consistencies we're seeing. The data reflected here is over a 30-day period. And it's normalized to every 10,000 devices and workloads. And so what this is showing you is in 30 days, for every 10,000 devices and workloads, what we expect to see are over 14,000 events. When you think of the original problem of overworked staff and things like that and slow processes, quite often what you have is analysts trying to work on the event problem because there's no connection between different products, there's no context to what's going on, they're not looking at behaviors, it's all kinds of different things. A great example on threat intel is that, like, if you got a malicious URL or IP, that would be an event, but there's no context to what else it means other than you knew it did something bad before, so there has to be a lot of investigation. But by looking at the behaviors, we're able to distill those events down every 30 days for 10,000 devices to 686 specific unique detections, being behaviors that map to the attack lifecycle, which ultimately goes down to 27 critical, 57 high. If you divide this by 30, what you actually see is on any given day for 10,000 devices, what we found the average is you get 2 hosts that are considered high and 1 host critical per day, which means that's where you start as an analyst. You say, you know what, these 3 devices, the 1 critical and 2 high, that's how I start my day, which is a far more achievable goal than trying to go through 14,000 events to make that decision. This is one of the values of using attacker behaviors for SOC visibility to cut down both time and staff and things like that. You still need security analysts. It's just we're trying to augment them to make their lives better. So to that point, what we really want to talk about is where to apply automation to SOC Visibility Triad. And I'm going to go through an operational flow from here to show you what that looks like in action, and then give you an example, kind of a case study of somebody we worked with over the years who has implemented the SOC Visibility Triad to gain efficiencies. So this goes along with the AI hype, right? There's a lot of claims about full autonomous systems, is the best way to put it. The thing is automation works great as a tool for reducing menial tasks, things like log collection, task creation, collaboration. It's good at looking at behaviors, but it can't make complex decisions. Example of deciding on 0 to 1 if something is malicious based on input, things like that it could do. But the reality is that you need to know when to automate and when not to automate, and you need to keep humans in the loop. You don't want to give all the keys to the machine. The concept here is not to remove analysts, but to let analysts move to higher quality work. Higher quality work would be things like threat hunting, for example. It's being proactive to understand some of the processes, and a lot of that domain knowledge of how your organization works exists within the human analysts. So the machines are very good at large volumes of data and distilling that down to high quality signal so that a human can look at that data and start to make decisions based on what he knows. A perfect example is that if you saw behaviors of an external command and control to privilege access from a host you've never seen before, which could be somebody working at home, to looking at taking data, the human analyst, rather than saying this is malicious, actually asks the question, is this approved or unapproved? And through an investigation is able to answer that and then make a decision on how to trigger a response within your incident response processes and your playbooks. So there are 3 sections for the SOC Visibility Triad, and I could talk about how the automation fits in here as well. On the left, we have the visibility that we mainly talked about. Then in the middle is correlation, and on the far right is the kind of the coordination response, incident response. So first on the left, for visibility detection analytics, this is where we really focus on endpoint and network. And really, there's another layer of logs in here as well. And so on the network side, so you know that within Vectra, what we really define as network these days is anything that's not endpoint. And that's important to point out as we move to the cloud and start to look at software as a service apps, that when we think of network, what we're really thinking of, what are the behaviors between hosts, the kind of communication things that happen, such as external remote access, remote processes, things like that. And what is the data source for that? And what we've learned is that's internal network metadata, or in the cloud, that's log data. That's getting into your Office 365, into your SharePoint, getting into how do you see traffic from these different software as a service apps. The endpoint focuses on visibility of what happens on the host. What are the kind of things that occur locally at a process level? What is the host doing? When you put those together, you do get that complete picture I was talking about of attacker behaviors across the MITRE ATT&CK framework. And you now understand how everything connects and what it does, with the goal to prioritize incidents. Not everything's going to require an immediate response to security operations, but you do want to prioritize the time. A lot of what's on the left is highly automated. This is a right place, taking large data of endpoint network data across hundreds of thousands of hosts or however large a network is. That's a great place to start to automate and reduce that workload to create prioritized incidents, which can then be fed into a correlation engine, which tends to be a SIM more often than not. You take a SIM and you start to take this endpoint data and this network data. You also start to combine it with user entity behavior analytics, application data, threat, vulnerability, whatever it is. This is the place where 2 things happen. 1, you are investigating as a human the contextual around prioritized incidents to answer the question, is this authorized or unauthorized? And 2, you're proactively threat hunting and not waiting for incidents to occur. One of the points of reducing the workload and automating the visibility detection analytics is not so that the human can continue to be reactive to alerts, it's so they can be proactive and start looking at processes and how systems work and how connections make. An example is we've pivoted to this remote work from home environment as most people left the office networks and started working remotely exclusively. The security team needed to get ahead of that and start to say, okay, so what are my new traffic patterns? How is remote desktop being used in my networks? How are people accessing servers? Are they going through the VPN? Is the encryption in place? Like, these are all questions that as you learn your attack surface, you start to learn from it. Threat hunting is not always about finding a threat. It's about learning about your environment and being proactive. And if you're always stuck on the left trying to figure out from a threat intel or something what's happening, you never have time to actually do this higher value work of proactively knowing your attack surface and searching through data and knowing what that looks like. So those two things are really what we want to look for at this stage. The ability to go through prioritized incidents and make a decision if it's authorized or unauthorized, and then proactively threat hunting as a human to understand other things that are happening and what it looks like. The outcome of that is orchestration automation of a response. You see the Thor tools, security orchestration automation response tools, or this is done manually. This is done through APIs, or this is done through native integrations. There's lots of ways to establish this, but the goal is that from the correlation and making a decision if things are authorized or unauthorized, the analyst is able to verify an incident, and that's what I view as an analyst's job, either from threat hunting or wherever you get a source. They're going to verify what they saw and make decisions about it. The first being, was this authorized or unauthorized? And if it was unauthorized, what are you going to do about it? And you get into playbooks and the response. And how you respond and what you do about it has everything to do with what the incident was. And what I mean from that is the way you treat data exfiltration is not the same as you treat a just opportunistic botnet. Maybe it's a spam relay or it's crypto mining. The way you respond depends on two things. One, your capabilities, two, the incident itself. So you have to understand that ahead of time and know, can I isolate on the endpoint? Do I have network access controls? Do I just block a port on the firewall? Do I need to lock out a user from my AD? Is that the right thing to do? Does an application need to be stopped from working? Do I need to disable Zoom on my network? Whatever it is, the response isn't consistent and you have to know what those are. This is another great place for automation, hence orchestration automation. So what you end up seeing here is you can automate on the left, you can automate on the right, and you have a lot of human interface in the middle. And this coordinated system, what we found, works extremely well. So with that, I'm going to give you a real example here. So EDF and Man has been a customer of Vectra for, I'm thinking here, oh, it's been we're at least 3 years into this journey. And they have a really smart team there. So EDF and Man is a company, they're based in the UK. They're pretty large and they're old. They've been around for over 100 years as a commodity trading business, over 7,000 employees, 60 countries. I mean, they're a pretty healthy size company, yet by their own admission, they looked at themselves from a maturity model, from a CMMI. They looked at themselves as a 1 to 2 in their capabilities, which really means the SOC was reactive to incidents, and they had an extremely small team. And in fact, a team of like 2 people when I say small for such a large company. And as many of these industries are, they've been around for quite a while. Cyber threats were not something they had to worry about in their regular business, but over the years, they've become largely, as every company, largely digitally driven, IT-centric, and very dependent on network resources, even more so now. So they came to us, and what they talked about is they have a really smart security team there, and they talked about the reality is we're not going to get a huge budget for information security here at EDF and Man, but we know that we need to be more proactive. We want to be ahead of things that occur so that we can reduce the impact. And they looked at a mix of vendors. It doesn't say it here, but they looked at Vectra, they looked at CrowdStrike, and then they looked at a managed Splunk instance. They took these 3 vendors to address the SOC Triad, and we knew this going in. It's like, all right, well, how do we build this visibility, and how do we build these processes when we candidly are not going to have a large internal security team, but we do have a large footprint? In other words, they looked heavily at automation and integration. Like that was absolutely a must and a requirement of building this out. So we have native integrations at Vectra with, among other vendors, we work directly with vendors like CrowdStrike and Splunk, and we have these native integrations so that as vendors, we play nice and we don't work in silos. And they were able to take information from these different places. Now, to solve headcount, they did use a managed service for their SIM. So if you imagine it's a managed Splunk with the data from CrowdStrike and Vectra going in, and it prioritizes the scores and starts to map out the host in real time to always tell you where to look and where to focus. By doing that, they've been able to take their internal team. So the managed service focuses on managing prioritized events, some other general functions they have during the day. And their team of 2 now focuses on security by policy, looking at mapping the standards, as well as proactively threat hunting, which means they're taking this visibility of data they have internal, not just to find attacks, but to understand how users are just using their network every day, what their attack surface looks like. The good news of this is after several years of building this program and getting it in place, they ended up saving a fairly significant chunk of budget compared to how they were trying to run the program previously, even when it was proactive based on the tool set they had. And they saved a ton of time. They cut down their process significantly. In doing that, the interesting thing is that the business of EDF and Man, who originally told them that you're already spending a lot of money on cybersecurity, we're not going to give you more, has been so happy with the performance of their program and how much it's turned around. It's actually created an increase of budget to them. So that's been a win-win for them to be able to increase their program at the same time being efficient and saving money. What they didn't do is hire more people. They still have the same staff of 2 people internal as they did when they started this. All they did is got smarter about how they use resources, leverage them. They use the managed service, but they're smarter about their managed service, and they feed that managed service and that SIM so that they know exactly what they're going to get out of it. And then they can leverage that same back end for their threat hunting and to do all their things. So what they achieved was the ultimate goal of efficiency within the SOC Visibility Triad. Able to see things across the attack life cycle so they can detect early before it's a problem, before data is stolen. I would call that highly effective and efficient, and this works at any scale. I've seen this, that's an example of just 2 people. I've seen this work in a SOC with 50 people plus. This goes either way, regardless if you have resources and scale of size, you need some automation and efficiency to go with it to augment the analysts you have. The whole goal of this is to reduce the attacker dwell time. We're not going to bring this to 0. That's not the intent. It's to bring it down so low that the impact is minimal and the attack becomes ineffective. Then, of course, streamlining your products, because one thing that EDF and Man did, they didn't just put in the people to build the triad. They start to score their vendors this way and say, here's our process and our flow across the board. How do you fit into this? What do you do? It becomes a way that you can look at all your vendors and say, let's make sure they work together. Let's decide what vendors we should keep, what we should not, and how we build our security operations so that we can get rid of the fat, basically, which ultimately leads to reduce SOC costs.